And today, what I want to focus on is talking about how customers today are using embedded cluster in production already and why we think it's a really great choice for shipping your Kubernetes application into customer managed production environments. So to start, let's do a little bit of a review on what embedded Kubernetes is. That's something we talk about here at Replicated. And embedded Kubernetes is where you embed a Kubernetes cluster in your application so that you can deploy that application anywhere, whether or not your customer has a Kubernetes cluster. And so this effectively packages up your application as a Kubernetes appliance. So you think about someone that ships like a hardware appliance and they have a box and it's got some software and things installed on it, and you just plug it in and you can start using it. Embedded Kubernetes is a very similar concept where you have a Kubernetes appliance where you can ship, in this case, like a single binary that can install Kubernetes, your application, all together so that the requirements on your customers are very low. They just have to give you a machine, they can run this install command, and they can deploy, get the cluster and the application all together. And so as part of embedded Kubernetes, we've recently introduced embedded cluster as kind of the next generation product from Replicated for this embedded Kubernetes use case of bringing your application along with a Kubernetes cluster. And if you're familiar with Replicated, we have our curl project that many people are using. An embedded cluster is kind of the next generation of embedded Kubernetes here. And some of the benefits of embedded cluster and this embedded Kubernetes approach is that it can be installed very quickly. So, embedded cluster takes only a few minutes to install, which is great for getting it up and running quickly. It's great for development, for POCs, for a lot of different use cases. It has very few host dependencies. So, for the most part, if you have a relatively modern Linux kernel, systemd, you're able to run embedded cluster. So there's extensive operating system support because we don't just support particular operating systems because we're not shipping host packages or anything like that. All the dependencies are statically compiled into the binary that we ship. So there's very minimal requirements. So most machines that a customer can bring can support running embedded cluster right out of the box with very little prerequisites as far as configuration and things like that. There's very little Kubernetes knowledge or interaction required. So if you're shipping your app to your customer and they don't have a Kubernetes cluster, they shouldn't have to go out and learn Kubernetes or even necessarily interact with Kubernetes. Their goal is to use the application that they bought from you. So they just want to get it installed and use it. And so embedded cluster does a good job of abstracting away from Kubernetes. Kubernetes is sort of the implementation detail of how your containers are running, but it's not a requirement that your customers necessarily understand it or interact with it to use the product on embedded cluster. There's also a guided admin console experience that is great for leading your customers through common workflows like installing and upgrading your application, configuring it, things like that. So again, rather than having to document a series of CLI commands that people have to figure out, it's very easy to follow this admin console experience to do the common workflows that your customers are going to want to do to use your application since that's what they actually bought and are paying for. And then unified updates for the application and the cluster. So because, thinking about this as an appliance where we're deploying these things together, they're getting upgraded together, which again, just takes some of that burden off of your customer where they don't even need to be thinking about the cluster. They just think about upgrading your application, and those cluster upgrades are going to come as part of that. And then lastly, enhanced multi-node cluster support, where if your application requires a multi-node cluster or an HA cluster for various reasons, that is fully supported within embedded cluster as well. So these are some of the benefits of embedded cluster. And if you think even particularly maybe about the first three up here, the fast installation, the very few dependencies, the abstraction away from Kubernetes, this can really make it great for proofs of concept. So if you're going into a sales pitch with a customer and you want to demo your product, if it takes more than a few minutes to install, then you're not really going to be able to do a live install for them because you're going to waste the whole meeting waiting for it to come up. Whereas if you're able to install really quickly in a matter of a few minutes, then you can really impress them, show them a full installation experience as part of your demo without having to kind of hand wave and leave the details for when they actually buy and have to go install it themselves and things like that. So embedded cluster, all of these benefits really make it great for development and for POCs, but ultimately embedded cluster is purpose-built for production. And that's something I want to talk about today is why, how we're doing that, why we think it's so good for production, and why it actually is a really great, maybe the best choice even for bringing your application into customer managed environments. So traditionally at Replicated, we have supported installing into existing clusters and into these embedded Kubernetes environments where the customer just brings a machine. And so the question that's often asked when, a software vendor goes to their customers, they might say, all right, does this customer have a Kubernetes cluster? And if they do, then we'll deploy to that existing cluster. If they don't, then let's go down the embedded Kubernetes path and we'll bring the cluster as part of our application. And this makes sense. This is how Replicated has positioned this for a long time. And this is kind of a natural way of thinking. If you have a Kubernetes application, find out if they have a Kubernetes cluster and deploy to that if they do. So inevitably, when we go down this path, this becomes our default path where most people are going to go and get a Kubernetes cluster. They're going to have a cluster already that they're going to use. And so using embedded Kubernetes becomes kind of the backup option in the case that someone doesn't have a cluster or can't get a cluster for themselves. But one thing that I'll challenge here is what if deploying to existing clusters can actually be a lot harder? And it can introduce security and process and complexity burdens that enterprises have when you have to deploy into their existing cluster. And ultimately, maybe you should only do that when it's necessary. And so, what if instead our first question was, does this customer have processes that require them to use an existing cluster? And if they do, we'll deploy to that existing cluster. But if they don't, then we'll use embedded Kubernetes. And if we reframe the question this way, our default option ends up becoming using embedded Kubernetes, where rather than saying, can you get a cluster? Do you have a cluster? If we use the cluster when it's necessary, but we default to using embedded Kubernetes, that switches the script a little bit. And so for the rest of this talk, I want to talk about why I think this is a really good way of looking at this and why embedded cluster and embedded Kubernetes can make it so much easier to deliver your application into your customers' environments. So let's talk about the production benefits of embedded cluster. And the first one I'll talk about here is controlling the whole cluster. So if you think of a bring your own cluster installation where one of your customers has a cluster that you're already going to deploy into, obviously the first thing is they have to have a Kubernetes cluster. So they need to procure one, they need to have one already. You might have requirements for what version of Kubernetes or different Kubernetes settings that need to be set up within that cluster. So there's work that needs to be done in advance to get a cluster and then to make sure that that cluster works for you. And then there's the ongoing maintenance of that cluster to keep it up to date and in sync with your application. Then on top of that, there's dependencies. Maybe your application needs a load balancer to get traffic into that cluster. Maybe you need to know the storage class that's available in that cluster that the customer wants to use so that you can use that for your persistent volumes. Maybe you have other infrastructure components like Cert Manager or Istio that need to get deployed first. And then maybe those things are, if they're custom resources, then it's cluster scoped. So they have to get deployed in that cluster with admin privileges, and they're available in all namespaces, and there can't be more than one instance of them. So then the versioning conflicts can happen. So this is just another set of things that your customer now has to manage outside of your application for the purpose of deploying your application. And then only once we get all of those pieces in place can we actually get your application deployed, which is what we were trying to do in the first place. So with this approach, there's just a lot of things that are happening outside of your normal software delivery of your application that customers have to do in advance and get right and keep up to date and in sync with your application. But what if you controlled the dependencies that got installed and the versions of those dependencies and the version of Kubernetes that was used, the configuration of all of those dependencies, the configuration of Kubernetes, and much more. So what if all of that became part of your application so that it was not only easy, but just natural to keep all of that in sync together as you release new versions of your application? Embedded cluster makes this really easy because embedded cluster, you're bringing the cluster with you. And embedded cluster gives you a lot of ways to customize that cluster for the things that you need to do specifically for your application. So at baseline, embedded cluster has tested defaults that you can override. So, I mean, using embedded cluster is as simple as about 5 lines of YAML in your replicated release, and you've got a cluster that you can deploy and embed inside of your application. But if there's things that you need to tweak about that, you can override them. That's possible. So for example, you can modify the K0s config if you need to alter the Kubernetes cluster itself. So we have customers that are changing the node port range so that they can use specific port numbers in their application. There's people who are using, a new feature of Kubernetes where you can pull your images in parallel to speed up the deployment process of your application. All of this is possible because you're controlling the cluster as part of your application and configure it the way that you need to best suit your application. All the extensions that are deployed as part of embedded cluster, whether it's storage or our COTS admin console, all of those are deployed as Helm charts with modifiable Helm values so that you can tweak them again as you need for deploying your application. Plus, you can deploy your own Helm charts as part of the infrastructure before your application. So if you have that use case of needing Cert Manager or Istio or something like that deployed first, you can put those into the embedded cluster. They'll get deployed and be there before your application gets deployed. And then lastly, if you're doing a multi-node cluster, there's support for node roles, which lets you label the nodes out of the box. So instead of having to have your customer take an existing cluster and label the nodes so that your workloads get distributed to the right places, all of that just comes baked in. So your customers can just create deploy your application, the nodes will get the right labels, and the workloads will distribute themselves automatically. So all of these are benefits of how, when you embed that cluster into your application, you can control these things and make it a lot easier to deploy the application. So instead of the customer having to do those lower levels of that pyramid just to get to the app, you can deploy the app and control all of those levels of the pyramid yourself within your application release. So another one of the benefits I want to talk about is installation success. Obviously, if you're trying to deploy your application to customer managed environments, getting it installed successfully is, arguably one of maybe the most important thing that you need to do, and often one of the most challenging things. One of the reasons that SaaS is so ubiquitous and beneficial is because it's so much easier to deploy to your own infrastructure and let your customers use that, as opposed to deploying into their environments with different security constraints and proxy servers and all these different things that enterprise environments can have. So being able to install successfully and reliably is probably one of the most important things with distributing your application to customer managed environments. So our goal with embedded cluster is a 95% installation success rate. And that's just a first step. Of course, we want to make that even higher. But out of the gate, what we're striving to get to right now is a 95% installation success rate, which means that when you have a customer that installs, 19 out of 20 of your customers should be installing successfully on their first try. And this doesn't mean that if you bring, a swarm of engineers to the call and work together, you can get them installed in a few hours. This ideally means that you can give your customer your instructions, your installer, they can run it themselves and successfully install 19 out of 20 times. And that 20th customer maybe has some unique circumstances in their environment that require a bit more work to get it working. But, out of the box, we're shooting for 19 out of 20 customers to be able to, without assistance, install your application successfully on their first try. So that's a pretty lofty goal for installing into enterprise environments because of the differences in these environments. So installation success is a key thing, but how are we going to get there? So a few ways that we're going to help achieve that goal of 95% installation success is, first, we're marshaling the experience of thousands of enterprise installations. So, Replicated has many customers, and then our customers have many thousands of customers with different environments. So Replicated has a view into more end customer environments than your company likely ever will have, because we're aggregating across all of our different customers. And so with that experience comes a lot of exposure to different enterprise situations and circumstances and security procedures and things like that, that help inform how we build embedded cluster to make it work better. And so it's difficult for a software company who is trying to go on-prem to be able to imagine all the things that could happen before they go to that first customer. But with Replicated, we're able to take that experience and do that thinking for you so that when you go to that first customer, it should just work. Then as part of that, we're working to continue to test on more restrictive environments. So enterprises might have a CIS hardened environment or a very minimal environment with very few dependencies pre-installed on the machine. So we're looking to continue to test on these types of environments to make sure that embedded cluster can run anywhere that it's asked to, or if there's something in that environment that makes it impossible to run, that's where our pre-flight checks are going to come in. And so we're going to pre-flight for everything that could go wrong, for all the prerequisites, the requirements that are necessary for embedded cluster. We're going to have pre-flight checks so that those things can be identified before the installation even starts. And then something we've done around pre-flights is we're trying to use them to guide the user to success. So we don't have any warnings in our pre-flight checks anymore because warnings are ambiguous. Do I care about this or not? Is this actionable? So our goal with the pre-flight checks is for every failure to not just say this failed, but to give remediation steps, to point the user towards what they can do to get their environment into conformance so that if they rerun that installation, it's going to succeed. So that's kind of the path that we're taking to help ensure that embedded cluster can be installed very reliably into all these different types of customer managed environments. So now I'm going to do a quick demo just to show an example of what that looks like, of ensuring installation success in a customer environment. So over here, you should be seeing my terminal, hopefully, because I think I'm sharing my whole screen. But I've got an environment here that I want to install an application with embedded cluster. So I already have my installer here. So my application's called Gitty. So I have, this is a binary here. I've got my license. So this customer is going to start by running the install command and passing their license. Now they've got to provide the admin console password real quick. And the first thing that's going to happen is we're going to run those pre-flight checks and see what happens. So this is going to help inform us on whether this environment is suited for the installation. So we can see here, I've got 3 pre-flights that failed. The first one here says that there was an error connecting to replicated.app. Make sure your firewall is properly configured. If there's a proxy server, you can use these flags to configure that. And then it also gives me the static IP addresses for this address, for this domain right here, in case maybe I need to allow list that domain based on the static IP addresses. Same thing for the second endpoint. So these are the 2 endpoints that are necessary for an online installation of embedded cluster, replicated.app, and our proxy registry, proxy.replicated.com. So again, same message, kind of telling me check my firewall. If I have a proxy server, I need to configure that. And then here's my IP addresses. And then lastly, port 30,000 and the TCP protocol is required here, but something else is already using it. So I can either relocate that conflicting process, or I can use this flag to select a different port. So taking these in the backwards order, okay, port 30,000 is already taken. Well, I went ahead and I ran this HTTP server on port 30,000. So that is true. I've got something else on this server that's already listening on port 30,000. And this server is super important to me. I don't want to relocate it. So I'm going to leave it there. So now I know I can pick a different port with this flag. So I'll keep that in mind. And then for this demo, I, sort of contrived this situation where I set up some IP table rules that blocked access to those IP addresses. Obviously, no one would have rules that specifically block these IP addresses, but they might have rules that block every IP that they don't recognize, and you have to allow list those IPs. So in this case, my server isn't letting me connect to those things. So I'm going to just go ahead and drop all 4 of those rules there that were blocking the connection. So at this point, I believe I've resolved this connection issue here for both of these endpoints. And then I've got a path forward on the port. I just need to keep this flag in mind. So I'm going to go back to my install command and I'm going to rerun it but I'm going to specify an alternative port. So 30,000 is the one that's used. Let's just try 30,001. Set my admin console password again. Run the host pre-flights again. And this time, since I've addressed the feedback that I got here, I would expect that to work. And so now the installation has succeeded. So this is a small example, but these are the types of things we're trying to do in embedded cluster to pre-flight for all the things that are necessary and then give really actionable remediation steps to guide people towards success and towards what they need to do so that you can kind of think of this as a contract that we're trying to establish where if there's anything wrong in the environment, our pre-flights should detect it. And if the pre-flights detect something, they should tell someone how they can go about fixing it. And if they fix those things and they address all of that feedback and then they rerun, they should be able to install successfully. So that's just an example of how we're looking to achieve that 95% unassisted installation success rate by taking all of our experience, putting it into these pre-flight checks, and then guiding people towards installation success through those. So just quickly looking at a customer testimonial here, we've got a number of different customers that are already using embedded cluster in production in online environments, air-gap environments, behind proxy servers, different operating systems, all sorts of different things. We've got a number, people that already have double-digit installations in production. So there's a lot of embedded cluster use in production already. And we have here from a customer, Raza, a quote where they say that once the customer provided a VM, installing their air-gap product only took 30 minutes, which is a crucial factor in delivering POCs rapidly within highly regulated and secure environments. So this was an environment that was in a highly regulated industry. It was air-gapped, it was very secure, but once that customer got a machine, it only took 30 minutes for them to be able to install successfully. And we were able to have a really close partnership with this customer to make that possible as they rolled out this application. So this is just one of many examples of customers that today are already using embedded cluster in production and seeing it make it very easy for them to successfully get their applications installed into their customer managed environments.
Thank you so much. That was really amazing. I think there's so much that we can do if we actually are able to achieve that 95% install success rate. So I love seeing that demo because I think it really does kind of illustrate the possibilities of what a phenomenal installer we've built in the pre-flight checks and being able to just like address all the issues at once and not having them come up piecemeal. So really excited about what you and the team are building. So thank you for your leadership on that.
Of course.